Okay, so here what we're going to do is we are going to look at the net electrical force on each charge, 1, 2, and 3. And we're going to find what those are in terms of K, Q, and any fundamental constants. Or sorry, K, Q, and A, and any fundamental constants. So looking at this, we have Q1, and Q1 is negative, so it's going to be attracted. Q2 and 3 are going to be attracted to Q1, and Q1 is going to be attracted to 2 and 3. So they're both going to pull to the right. Now, 1 is going to pull, 2 is going to pull 1 to the right with a force of 2 on 1. And since 3 is the same amount of charge but twice the distance away, and it's an inverse squared relationship, it's going to pull with a quarter of the size. So this would be a force of 3 on 1. Now to find the net electrical force in terms of K, Q, and A, force of 2 on 1, we're going to add those two together. We're going to have K times 2Q. Remember, all we have to do is take the absolute value because we already assigned our directions up top, times Q over A squared. We're going to add to that K times 2Q, so that's Q1. Q3 is Q, and then the distance is going to be twice that squared. So we're going to be left with 2KQ squared over A squared plus 2 over 4 KQ squared over A squared. All right, when we find the common denominator, which is 4, we will ultimately end up getting 10 force. So that is going to be multiply the first fraction here by 4 over 4. So you have 8 over 4 plus 2 force. That reduces to 5 halves. KQ squared over A squared. That'd be the electrical force on Q1. Q2. All right, looking at Q2 here, we see that Q2 is positive, so it will be attracted to Q1. So Q1 will pull to the left. So here we are going to draw force of 1 on 2. And then Q3 is positive, so it will repel Q2, which means it will push it to the left. All right. So here we are going to have force of 3 on 2. Okay, now to determine the net electrical force here, what we have to do is the following. The net electrical force on 2 is going to be the force of 1 on 2 plus the force of 3 on 2. So this is going to be force of 1 on 2 is going to be K times 2Q times Q over A squared. Added to that is going to be the force of 3 on 2, which is KQQ over A squared. Ultimately, this is 3 times KQ squared over A squared. That'd be your answer for the net electrical force on Q2. And then finally, if we look at Q3, Q3 is going to be pushed to the right by Q2. So this would be the force of 2 on 3, and it will be pulled to the left by Q1, which will be the force of 1 on 3. All right, so to determine that net electrical force, we are going to have the following. the net electrical force on 3 is going to be the force of 2 on 3 to the right minus the force of 1 on 3 to the left. 2 on 3 to the right is going to be K times Q over A squared minus K times 2Q over 2A parentheses squared. All right, so when we make this calculation, we are going to get 2 in the numerator, 4 in the denominator, which will be 1/2. And when we subtract it from 1, our answer is going to be 1/2